So welcome everybody to our April Any Bites. Apologies for late cancelling of the last one due to illness. Hopefully that one will come back at some point. I'm just waiting for the speaker to kind of come back to us with an alternative date. So it's April 2022. And usual order of business, our events page, our Twitter, and our email as well for any kind of inquiries that you've got. We have a code of conduct which you can see at our website, and then any comments, suggestions, anything you'd like to know, anything you'd like to suggest for us, bring it to me or Brett on Twitter, if you would please. So tonight we've got Peter Gallagher here. Now anybody who's ever been to DDD North will know Peter and will have seen him around and doing presentations and stuff like that. He's an Azure MVP, and he also hosts a huge number of other meetups. Okay, down in Nottingham, is that right?
That's right. Yeah, I collect them. You know, like those stickers when you were a kid in the playground.
And he's currently working at Octopus Deploy. Other than that, his bio is a mile long, so I'm not going to read the whole thing out. It just goes on and on and on. It's really annoying.
Sorry about that.
But tonight, he's here talking to us about, I'm hoping a robot army, but we'll settle for a robot arm for now. .NET 6, Raspberry Pi, Blazor and SignalR. So I'll stop sharing my screen and hand over to Peter.
I like the idea of a robot army. Funnily enough, I gave this talk as a workshop along with Cliff Aegis for all of the reactors around the world. All of the staff from the reactors joined, as well as a few Microsoft FTEs, and the workshop allowed them to be able to build this robot arm themselves. And when it was finished, you can control them all simultaneously. So it was like a robot army. It was quite cool, actually. It was, geez, every time I share my screen, I forget to click that little thing that says share your sound. There's not a huge amount of sound, if I'm honest, but it'd be good to have it. Is that sharing all of my screen, or is that sharing just one tiny little bit?
Just the slides.
Oh, okay, because it's a red box around it and it's sharing like the top left-hand corner of it according to my slides. Never mind.
I can see the yellow, sorry, the green bar at the bottom.
Oh, good. Yeah.
It looks like I can see the whole thing.
Yeah, happy days then. So I am going to just pop this over here and make sure that I can see all of your lovely faces, if there are lovely faces at some point on all of my screens. Cool. So hopefully you've come along to watch me talk about the Raspberry Pi robot arm with .NET 6. If not, if you're looking for cooking, then I'm sure you'll just hang on for a bit and there'll be one of those in the Northeast before you know it. So if I just get my slides up here. So yeah, you heard a little bit about me there. I'm Pete Gallagher. I am a senior solutions architect at Octopus Deploy. I've only been there for 3 months, so I know nothing at the moment, like that famous waiter from Fawlty Towers would tell you. I'm a Microsoft certified trainer, an Azure MVP, a Pluralsight author. I've been doing IoT dev since before there was IoT, actually. So yeah, quite a long time, as my grey hair will attest to. But yeah, making things like internet connected Royal Mail stamp vending machines and everything from that all the way through to helping conserve wildlife in Zimbabwe. So yeah, and everything in between. But so this is the sort of stuff I've sort of grown to love doing over the course of my life. I'm branching out now, joining Octopus Deploy essentially to do DevRel is really what I'm doing there. But outreach into the community, which is this sort of stuff that I would be doing like this in the evening, but now I'm doing it and getting paid for it, which is nice. I'm also a Meetup organiser, as was mentioned just there a minute ago. and I organise .NET Knots, Knots IoT, and when we're in person, then Knots Dev Workshop, and also a local group called LATI, which is a Loughborough-based organisation for high-tech stuff that we work in conjunction with the local council to talk to high-tech companies. So yeah, there's a fair few things. I'm also part of the Agile Engineering podcast, and I'm part of a Twitch channel called Azure Live, and on there, when I get back to it, I run a little show every Tuesday evening called IoT Live as well, but we've not done that in a while, but I will get back to that. I've just been busy like everybody. I'm also a STEM ambassador and a co-club organizer, mainly because I've got 2 little girls at home, and I want to make sure that they've got access to all of the STEM subjects, like everybody should really. It's quite important to me to make sure that everybody's got access to that sort of information, that sort of learning. So moving on a little bit, tonight we'll talk obviously about .NET 6. Actually, you know, it's kind of a lie, and I always like to call this out at this point. This will work all the way back down to 3.1. So .NET 6, because that's the latest one, and it works on that, obviously. But you'll find, if you look at the repo, it references .NET 5 even. So, you know, the .NET 6 part is just so I don't look like I'm talking about old tech, really. But either way, this is important. We'll talk about how we can get .NET 6 onto your Pi. And then we'll look at the Raspberry Pi GPIO, general purpose input output, and then the circuits we'll be using. And then we'll do an IoT version of Hello World. Then I'll move on a little bit and talk about how we can use other people's code to drive servos, which is quite important for our Raspberry Pi robot arm. Then we'll look at how we can then integrate Blazor and SignalR into our project. And then I'll demo a few things at that point. And then if we get some time, then we'll do some Q&A. So briefly, .NET 6, most folks will know all about .NET 6, but it allows us to be able to target pretty much any platform we like now, everything from desktop to AI. And in the middle right there, you'll see IoT, which is the boon for us. There's a few new things in .NET 6. So we get ARM64 support. ARM64 is becoming more and more supported now, with even the Raspbian operating system having a 64-bit flavor. Until just recently, you needed to use something like Ubuntu 64 to get that to work. But now .NET 6 supports ARM64, so that's pretty important. .NET MAUI, which my friend I mentioned earlier, Cliff Aegis, loves. He's busy playing with that. Global usings, which are cool. Filescope namespaces. Geez, easier said than done. HTTP3, record structs, and async main. So just a few things that are new in that. It's well worth moving from 5 to 6. Obviously, you'll find that 5, I think, was not an LTS, and 6 is. So I think it's that way around, isn't it? This is quite an old slide now. It's from Build 2020. We're just about to have Build 2022. But what I wanted to call out is that bottom right-hand square there, where 40% of people that are new to .NET are students. And in fact, that figure's probably changed now. But I found that quite gratifying, actually. I mentioned earlier that I'm a STEM ambassador. And to see .NET making its way into educational establishments is really important, where before we would have C and probably Python. .NET is finding its way in there, and I think it's mega important if we want .NET to carry on being adopted and improved, that we have people using it. And the only way we're going to do that is if people coming out of education are starting to use it as well. So yeah, I thought that was quite cool to see that. So how do we get this onto our Raspberry Pi? Actually, it could be quite difficult, and I had to borrow a few other people's work to get to the point where I am, including Shorty and of course Scott Hanselman back in the day. But there was quite a lot of individual steps, and if you weren't particularly au fait with Linux or Bash, then it could have been quite difficult. So I made a single line install script, so you can just run that single line there. Obviously, go check out the GitHub repo before you run it. Don't just trust me. I could be mining Bitcoin on your Pi for all you know. So go and check it out. But you can see in that GIF at the bottom the steps that it goes through there, and you would have had to have done all of these steps manually and get them right and do them in the right order. Whereas now it takes, you know, way less than a minute, and all you need to do is reboot after it's done it. And you've got .NET 6 installed and happily working on your Pi. And there's .NET 5 installers, .NET Core 3.1 as well, if you want to go that far back. You'll find all of that in my GitHub. Go ahead and check that out. But for this talk, we're using .NET 6, so that link there will do that for you. We're going to be looking at how we can control hardware from our Raspberry Pi, and so that means that we're going to be connecting physical hardware via wires directly to our Pi. So to do that, we'll use something called GPIO, which is General Purpose Input Output. And to interface to those pins on our Pi, we're going to use something called the system.device.gpio NuGet package, and that allows us to then control the pins on our Pi, and that will include just standard input output, things to be able to flash an LED on and off or read a button, but also things like SPI, which is a serial interface, PWM, which we'll come back to later, I2C, which is another serial interface. And actually, every time I see this slide, I think, am I just going to remove these? This supports the Raspberry Pi, but it also supports these older boards like the Beagle board, the Humming board, and the Odroid. But really, why even bother? I'd just use the Raspberry Pi and be done with it. It's great. It supports Linux, and this is another one, Windows 10 IoT. That's still around, but it's not supported. And if you've never heard of that, that was Microsoft's way of being able to get WPF onto a Pi. And it was okay, but yeah, they fixed things and broke other things all the time, and so it just never really worked. And I don't think there's been an update to that in a couple of years, if not more now. So I wouldn't bother with that anymore. And in fact, getting at least XAML onto the Pi is a lot easier these days. You don't need that. But this is a NuGet package, so you can install that any way you like. CLI is my favorite, of course, if we're doing .NET Core. I mentioned GPIO, General Purpose Input Output, and that is these pins down the left-hand side of the Pi. You'll see that there are two sets of numbering schemes here. This one closest to the pin is the board numbering scheme. You won't find these numbers on the Pi, by the way, but this is just, an overlay of what them pin numbers actually are. But top left pin, that square one, that would be pin 1, and then adjacent to that is pin 2, and below it pin 3 and 4, and onwards that way. And I can count, so I can do that quite easily. But if you want to be sadistic and really hurt yourself, you can use the BCM numbering scheme if you like. And these numbers here relate to the BCM chip on the board, the control chip for the GPIO on the board. So for me, kind of a historic numbering scheme, and you can go ahead and use it if you want, but now you're having to convert BCM into the physical number. So just don't bother, just use the board numbering scheme if you may. This is important. You'll see in a bit that we need to be able to specify this, and I just wanted to explain where those two numbering schemes come from. So that's good. The circuit I'm going to start out with is our standard Hello World circuit for IoT. And you'll see I've got a button, an LED, and a resistor. And I've got one side of the button connected through a resistor to the LED from pin 10, and then down to ground. That black wire is just ground. So that's going to let us turn this this LED on and off via the resistor. We need the resistor because otherwise the LED can sink too much current, and you can either damage the LED, which would be the least of your problems, or you can actually damage the pin on the Pi. So don't do that. We're then connecting pin 26 to one side of a little tiny button, and the other side down to ground. So they're them two numbers there, 10 and 26, you'll see in the code as well. So let's do a little bit of Hello World. So if I go across, I've got quite a lot of virtual desktops, you'll find. So I'll do quite a lot of switching left and right, and I'll probably get confused at some point and wonder where the hell I am. Can you see this toolbar down here? Can I actually move that thing out of the way? Let's see if I can click that and get it out of the way. No, can you see that? Can you actually see
we can't see your toolbar, I don't think.
Ah, that's good then.
We just see your terminal.
Yeah, that's good, because I can, and it's right in the way. But never mind. Can you actually get rid of that bloody thing? No, not very easily. All right, good. Well, so, it's gone now. Good. So I can do a .NET -- info here, by the way, and we can see that I've got version 6.0.1 of .NET installed. 101 actually. That probably isn't the very latest version, but what you don't do directly before any form of presentation is do any updates. So I've not, but it makes no odds. It's all good. You can see I've got the runtimes installed and the SDKs as well. And there's actually version 5 of the SDKs installed as well. But the global version of .NET I've got installed is 6.0.101. So what I have got, actually, if I go by one more, is some code here. And I'm just going to go through the code here, and then I'll run it up and you'll be able to see what it's actually doing. But right at the top, I've got some using statements, and here is that system.device.gpio NuGet package that I was talking about before. And that's allowing us to be able to control the pins on the Pi. And then a little bit further down, I always leave this console.writeline hello world in my .NET IoT applications, because sometimes you don't necessarily see anything happen. And it's good to know when it's actually started, because the number of times it's actually taken quite a long time to start and I've been trying to do something to it and it's not working, I've stopped it and then realize it's just not actually started up yet. So that at least tells me it's started. Next up, we create an instance of a GPIO controller, and this is what's going to do the heavy lifting of most of what we do tonight, actually. And you can see here I'm passing in the pin numbering scheme of board. Obviously, shout if this is too small. I think this is probably just about right text-wise, but if you can't see it, shout and I'll zoom in even further. Then we set up a couple of variables. The first one is this pin. And if you remember, if I go back to the slides and go back a slide, go back that way. We've got the LED on pin 10, so that's where that's coming from. And then we've got this light time variable, and I'm using that in a delay in a bit because we're going to turn the LED on and then back off and then back on. And if we do that too quick, you're just going to see like a slightly dimmer LED. It's not going to make any odds to you, so you need some time in between those ons and offs. Next, we take our controller, which we've created up above, and we open the pin 10, and we set it to be an output because we're going to drive the LED on and off. And then here we create within a try catch, as you probably should for all your code. We've got a while loop, and we're just going to sit there and we're going to write to that pin a value of high, and then we're going to use that light time just to sleep for a minute, and then we're going to write a value of low and then sleep again and then do the whole lot all over again. So it's just going to sit there and turn the LED on and back off and on and back off. And then when we quit, we're just going to close the pin, which is just good practice. So if I go forward a little bit, then this is actually live. You can see my hand there. So you can see down here that we've got the LED and the button that I showed you from the circuit. I think actually no, it's not going to let me do that. Sometimes you can zoom in on that, but I can't. But it's close enough. You should be able to see that in a minute. So what I'm going to do is I'm going to run this up, .NET run, and then switch back over to the camera. And then all being well, if everything works correctly, we should see a flashing LED shortly. There we go. The first demo works then. So that's positive, inspiring. I like that. Very simple and not much to it, really. There's not much code in there, but this is a really important step to take in any IoT learning experience, flashing an LED. And in fact, there's a quotient, a particular figure that a lot of board manufacturers in the learning space will use called time to flash. And it's how long it takes you to get a new board and then, get that first LED to flash. And actually, for the Pi, that's quite high. Because this is a full PC, the Pi, relatively powerful one these days, the Pi 4 certainly, and this is a Pi 4 with 8 gig of RAM that I'm using here. But obviously you've got to set the whole operating system up and then get .NET installed on that, and then whatever other things you want to do to be able to get the code on there, maybe install VS Code and things like that. So actually the time to flash is quite high, but as far as if you've already got that set up, then it's it's faster, and certainly that install script has made things easier for everyone as well. So yeah, that's that little bit. So I'm happy with that. I can flash my LED, but really what we want to do is make sure that we can read inputs and outputs. Now, I'm not going to do any live coding. In fact, I'm probably just going to paste in one thing in this whole exercise. But what I have got is a bunch of branches. So I'm going to flick between those and just show you what it is that I'm doing. So I've just moved to the branch where I can read my button. And what we've got here is the same GPIO at the top, of course. Everything else is exactly the same apart from I'm now referencing pin 26, which, if you remember, that was the pin that I've got one side of my button connected to. Next, we open the pin for the LED still as an output, and then now we open our button pin as an input. And actually what we're doing is using something called a pull-up in there. Has anybody done electronics in there? And feel free to come off mute and shout. And do you know why I would be using this input pull-up? And if no one knows, that's perfectly fine too. Ooh. If I go back to the circuit here. So I've got a button and I've just got both sides connected to the Pi. That's great. But in the world of electronics, often what you'll find is these pins, when you set them as inputs, the ability for you to be able to do that as either an input or an output means that underneath the hood, the pin is what's called an open collector pin. And really what it's doing is floating around. It's not really doing very much when you do that. Set it as an input and it's just going, I don't care. So historically, what you would have had to have had is another resistor pulling that input up to a known state. And then when you press the button, it pulls it down to another known state. So in this case, I would have had to have connected a resistor to a 5 volts or 3 volts in this particular case. And then when I pressed it, it would go 0. And if I didn't press it, it would be high, 3 volts. So 3 volts is high and 0 volts would be low. But the Raspberry Pi's got little tiny resistors built into it that we can activate with this input pull-up. So just bear that in mind if you go through some code, write it yourself. If you just put that as input, then it may work or it might not work. And sometimes it'll work, sometimes it won't, depending on how hot your Pi is and things like that. So bear that one in mind there. That's what that's for. Next, I've swapped my code out to make the most expensive way to be able to press a button and turn a light on in the world. So I just read the value of my button. And actually, this seems backwards. But if you remember what I was explaining there from my circuit diagram, internally, this is actually sitting high when it's doing nothing. So a high is a true value. And when you press the button, it goes low, which will be read as a false value. So you can see if it's false, I turn the LED on. So it seems a little bit backwards until you understand the electronics and the reason why it's doing it. And if I'm not pressing the button, then I don't turn the LED back on and just leave it as off, which is fine. No delays or anything in this one. It just loops around forever. And then again, we close the pin at the end. So let's run that one, make sure that one works. And this is one example of why you'd want that hello world in there. It didn't particularly need it on the last one because it flashed the LED. But on this one, it does nothing until I press the button. So now I know I can press the button. You've got that example there. You do that on a slower Pi. It takes a while to actually build that and run it. So it's good to know when it's done. But I can press that button now. Tick, 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 and there we are. There's my LED turning on and off. And as I say, that's a really expensive, convoluted, time-consuming way of connecting that button to the LED. But now we're able to control the output of those pins by flashing an LED, and also we can read inputs. So that's a big step now, because you could go away and do quite a few IoT projects with just that facility. We're not obviously going to stop there, but that's why it's hello world. Read that button, flash that LED. You know that you've got some sense. Everything's building. It's running correctly. It's controlling the inputs and the outputs, and then you can start your journey after that. So I'm going to stop that code and go back to my slide. So next up, we're going to talk about device bindings. So if you want to do anything more complicated, you can absolutely write the code. But there's something called the IoT.device.bindings NuGet package. And what this is a bunch of somebody else's code that's been written for exactly this purpose. And it's got built-in support for things like BME 280 temperature and humidity sensors. And if you're someone like Cliff Aegis and I, in fact, that is horrible, because that is the next hello world that nearly always happens when you want to do the next thing after flashing a button. And it gets really boring when you see, every single tutorial for every single board always hook a BME 280 up and find out what the temperature and humidity is in your room. But there is a good reason for using that, in that it gives you some usable data so you can make the transition then and start adding the cloud in, because, OT isn't very interesting. You want IoT. So, yeah, that's why that's there, but a little bit boring. I showed you all of the pins on the Pi. You can get I/O expanders as well, so you can add more inputs and outputs to your Raspberry Pi, and so there's control for that. They'll use either something called I2C, which I mentioned, or SPI, which I mentioned, so serial protocols to talk to these chips to be able to, set things as inputs and outputs and read those inputs and drive those outputs on those chips. The Raspberry Pi's got something known as hats, which is hardware attached on top. And they're little boards that plug into those pins, and they've got a bunch of things already built onto them. The Explorer hat is one. The Sense hat is a really interesting one. And that's got a bunch of little LEDs and a matrix and some buttons and a temperature and humidity sensor, of course, a gyroscope, and a few other things on there now, light sensors and IR sensors and stuff like that on the latest ones. But actually, there's 2 of those and 2 Raspberry Pis sitting on the space station at the moment that originally Tim Peake took up when he went up there. But they've just sent up Raspberry Pi 4 versions with the latest version of that Sense hat. And what they're allowing children to do in schools is to be able to write code that runs on those 2 Raspberry Pis in space and conduct experiments of their own, which is, again, I mentioned I'm a STEM ambassador, and that's fantastic for me because if you want to energize anybody, actually, not just children, into wanting to try STEM subjects, then tell them to be able to run it in space, and immediately you can see lights starting to turn on in the head. So yeah, I like that. But you'll see the next item on the list is servos, and we'll talk about servos. But controlling servos is not as straightforward as just turning it on and off like an LED. There's more control required. And so somebody's written some code to allow us to be able to control servos as well, which is great. It means we don't have to do that. If you go and check out that NuGet link, and in fact, if you check out the GitHub repo underneath that, then you'll see all of the devices that it supports, and there might be 30 or 35 different devices in there. So loads of stuff you can just explore. You could buy one of those IoT packs off of Amazon and probably plug a great deal of it into your Pi with the right circuitry around it, and the code will be there for you to use it. So the more interesting part of our circuit is where we want to start controlling our robot arm. And so you can see there, that's sort of an overview of what it looks like. You can see there, sort of right in the very middle, what I've done is I've bought this little servo control board. You can do this all yourself if you wanted to, but one of the things to bear in mind is that servos, and again, I'll talk about those in a bit more detail shortly, little motors, they actually take up quite a lot of power, and certainly if they stall, as it's called, when they try to start, you can end up killing the pins on your Pi quite easily, just drawing too much current. So you can buy servo control boards, and you put a set of batteries into it, and you can see I've got some batteries there, middle right. So that handles the power side, and all you need to do then is send the control signals to this board. And then it combines the power and the control signals, and you'll see that in a minute on the other side, and lets your servos just do their work without you destroying your Pi. So zooming in a little bit, I've got 3 servos in my setup here. And you'll see those in action shortly. And I've got one pin here connected to ground. Now, when I bought this board, and if you do buy this board, and the parts list's all in the GitHub repo, so you can go ahead and find that. Bear in mind, I made the mistake of thinking that first pin was actually channel 1 because of the labeling on there. It's not, it's ground. Nothing worked the first time, and I thought, oh, this is rubbish. My code doesn't work or the board doesn't work. But really, I'd just not put ground on it, which is obvious. So yeah, that first pin 25 there, I've got connected to the ground pin on this board. Then I've got another servo connected to pin 35, and another servo connected to pin 13, and another servo connected to pin 12. Now, I'll circle back to this as well later, but actually there's only 2 what's called hardware PWM channels on the Pi, but you'll see I've got 3 servos. So what we have to do is use software to control the other one. So that's just something to remember when we come back to that in a bit. On the other side of that board, we've got all 3 of our servos connected. Now, I've got yellow, red, and black as the wires there. Actually, that was because when I created this, those are the wires that came out of that part when I put it on the parts designer. But actually, the ones on my board there are going to be yellow, red, and brown. But the yellow one, in this case, this far left-hand one, will be the control, and the red and the brown wires, they're going to be the power. So control, as long as you get that, you see that tiny little C just above the end of the arrow, that's telling you which is control, and then there's a plus and minus next to it. So power and ground. These servos, by the way, dead cheap. You can buy a pack of 10 for about £1 from Amazon. So even if you do break one, doesn't matter. You've got 9 more in the pack. And they're nearly always the same. So as long as you can plug them in, then it'll be all right. Even if you plug them in wrong, it's not really going to make any odds. It just won't work. So moving on, I said I was going to talk about servos. So they're basically motors, but they work a little bit differently to motors. Essentially what we've got in the case of our robot arm is 180 degrees of freedom for this servo to be able to move in, this little robot arm controlling motor to be able to move in. And to do that, we use something called PWM, or pulse width modulation. So we have big pulses and small pulses with bigger and smaller gaps in between them. And the variety of those pulses and the widths of those pulses will determine where this servo floats there in that particular location. So if you imagine if we got a small pulse with a long gap in between it, then the servo would go one way. And if we get, say, like an equidistant gap and pulse width, then it'll sit in the middle. And if we get sort of a big pulse with a little gap in between it, then it'll go the other way. And then you vary then that the width of that pulse to determine the direction, the angle of that servo at that particular point. There's a little bit more to it than that, but that's the concept at least, and that's pulse width modulation. So we could do all of that manually, but again, I mentioned that system .device.GPIO, that's got the PWM in it, that's great. But that device bindings NuGet package, that sits on top of that PWM control and then allows us to just tell it the angle that we want to go to pretty much. So let's see what these servos look like. So if I go back to my code and switch to the next branch, we can move our servos just here. And I'll go through the code and then I'll run it and you'll see how it works. So I've still got GPIO in there because I need that. That's where my PWM is coming from. And you see that system.device.pwm there. And we have drivers as well. So that allows us to be able to control the PWM. But that's just that pulse width. That's not actually any more control. So we bring in the IoT.device.servo motor there and use that for actually controlling the servo motor. And that's going to make use of the PWM from the system.device.GPIO. So there's a hierarchy there to bear in mind. Next up, of course, the ubiquitous hello world. And then we create our first PWM channel. And we pass into that the chip and the channel we want to use. There's only one chip, PWM chip, on our Raspberry Pi, so that's why we've got a 0 in there. And the next we pass in the channel, and there's 2 channels, and you can see that there's 0 here and 1 below it. And then the next we pass in I think that's the frequency there that we're going to work at, and just leave that at 50. That's just the default, so just leave it at the default. It's going to be perfectly fine like that. Next we create a servo motor, and that's coming from this servo motor up above. And we pass in that PWM channel that we've created. And then we tell it the maximum degrees of freedom that we've got, and that goes to 180, as I explained. And then we've got sort of the minimum and maximum pulse widths. I mentioned that you could buy these servos dead cheap from Amazon. You might find that one's not the same as the next. So you may find that you've got to tweak these a little bit if it doesn't go all the way one way or all the way the other way. Developers around IoT don't like end stops anyway, so I wouldn't recommend you go all the way to the end stop. It causes all sorts of problems, but that's what those 2 things are doing. So I create the first PWM channel there, and then we create the second PWM channel here. And then them 2 pins are assigned on our Raspberry Pi, and we're using those, and I showed you those in the circuit. But next up, we're creating a software-based servo motor here. Actually, it's a software-based PWM channel that a regular servo motor is using. So this is quite nice. This software PWM channel, though, that's actually coming out of this IoT.device library here. Somebody's written some code to make a software-controlled PWM channel. And it's pretty much the same, only we tell it which pin we want to use. So pin 27 is the pin that we're using for that. And then you don't need to worry too much about these. They're just set up bits that you can leave at their default. The one you do need to worry about, though, is this true on here. And what that's doing, it's putting the timer, the underlying timer that the software PWM channel is using, into what's called high accuracy mode. And if you don't do that, like I did for the longest time, then what you'll find is that it's rubbish, because actually being really accurate with timing on any real-time operating system is almost impossible. If you're going to sit on top of that operating system and be at the behest of all of the other services, you'll find PWM doesn't work very well. But what this does, this cuts out all of that, and it just goes straight to the bare metal basically, and gives you a high accuracy timer to use. And then everything just works nicely. And in fact, it works just as well, or I think in some cases better, than the built-in PWM modeling. Once you've created that software PWM channel, then you just pass it straight into the same servo motor that we're using above, so no difference, till it's 180 degrees. I modified these ever so slightly because I think actually I was just messing around, but as I say, you can, if it's not going all the way one way or the other, then that's what that's for. Next, we take our 3 servo motors and we start them up. So all that does, that just initializes those PWM channels, assigns those pins under the hood, and just starts the whole process running, which is, you know, a good thing to do. Next, I've got my traditional forever while loop, and in there I've got some code that I've got this move to angle routine down here, and you'll see I use that later. It just makes my life slightly better. But all that's doing under the hood is taking the servo I pass in and the angle I want it to go to, and using that right angle function there to be able to set the angle of that servo. So rather than us having to deal with pulse widths to be able to set the particular angle, we can do it nicely with this right angle command function subroutine. So I'm going to make my servo arm dance, is what this piece of code is doing. So servo motor 1 is going to go to 70 degrees, servo motor 2 to 20, servo motor 3 to 80, with delays of 2 seconds in between them. And then servo motor 1 will go over to 150, servo motor 2 to 50, servo motor 3 to 150. And you'll see actually these will become known by different names of rotation, reach, and grab, because they're controlling the different elements of the robot arm. And then it just sits and it does that forever. And then at the end, it stops the servo motor. If you don't stop the servo motor, what you'll find is that it'll actually push against you. When you stop it, you can move it freely because it's not actually being controlled. So it's quite important to do that, especially if you've left it in a funny angle and you kind of just want to move it back up. So that's what those 3 lines are doing. So let's see that running, shall we? Boop, boop. So over to the camera. And good. I've done this before and I forgot to put the batteries in. I always pop a battery out so it doesn't use all the power up. There we go. Look, so and hopefully you can see that moving. There we are. Boom. It's jerky as hell because I'm telling it to go between 2 angles, but it's just exercising all of the servos. And you can see there's one that does rotate here. Whoop, there we are. And there's one that does reach there. And there's one that does grab at the top, little pincers. When I first did this and I didn't realize about that high accuracy software PWM option there, I was using the grab in that software PWM because I was able to just tell it to grab or not grab, and that's all the control it gave me. But actually, you'll see in the demos later that with the software PWM in high accuracy mode, it works really well. So yeah, that is our servo motors running, and we could just stop there and congratulate ourselves, go to the pub and drink beer. But that's very boring because we actually want to exert some control over this crazy robot arm. So let's go and stop that. Nope. Stop ye. Go back to my slides, I think. Yes, let's do that. So that's great. We're moving the Raspberry Pi controlled robot arm around with .NET, and that is actually quite cool. Because now we're into being able to do all sorts of different stuff. But when I looked at this, if you've ever seen sort of any of my older talks, then normally I'd be talking about Azure IoT and things like that, because I'm quite well involved in that space with Microsoft. But I didn't want to do it that way. What I wanted is like a real-time control to be able to move the robot arm as you will, and IoT Hubs doesn't really give you that. It's not real time, not really. So what is real time though is Blazor and SignalR. So starting with Blazor, so this is a single page app framework, and it's going to give us a way to be able to create .NET applications both on the server and on the client. It's actually created as a pet project by Steve Sanderson, a Brit. And he took it as a demo to a Microsoft conference, demoed it, and a bunch of folk from Microsoft saw it and went, oh my God, we need to have that. And ever since then, it's been going from strength to strength. What it does in broad terms is replaces the JavaScript elements of your application with C#, which a lot of people like. Obviously, if you're a JavaScript dev, sorry about that, but you can still do JavaScript. It's perfectly fine. But it's based roughly on the Razor syntax under the hood. So if you've used ASP.NET, then it'll look quite familiar to you. There's a load of different flavors actually, but the flavors that I'm going to concentrate on today are server side, and that is what it says it is. It's going to run on the server, and then your browser becomes a little thin client, and all it gets is updates to the DOM over the wire. Actually, it uses SignalR under the hood to coordinate those changes. So if you've got something that you want to change on the client side, SignalR is used to communicate that back up to the server. The opposite side of this is something called client side and WebAssembly. And so this is actually going to be almost creating a virtual machine in your browser. And it's going to run full .NET DLLs in your browser. And this is the part, essentially, both of these are doing this, but this is the real part that's replacing the JavaScript on your machine there. And most folk you'll find will do client-side WebAssembly because that's the in thing these days. But it is good if you're a .NET house, having to go and learn JavaScript or bring people in and train them on .NET and JavaScript maybe could be complicated. So having just a single language under the hood can be a bit of a boon. This runs without plugins, so it's not Silverlight, it's not Flash. This runs natively in any modern browser. Yeah, actually, I can't tell you about Mac because it seems every other day they support or don't support some stuff. So, yeah, but every other modern browser. The SignalR element of this gives us the real-time functionality between two or many points, in fact, based on ASP.NET stuff. And it was created by these two clever folk, David Fowler and Damien Edwards, way back in 2011. So this is really mature by now. And it enables us this bi-directional real-time communication between 2 points or many points in actual fact. It supports at the top level WebSockets for the fastest and the simplest connection, but if it can't do that, it will automatically drop down to server-side events or even this long polling, but God forbid you'd have to use that. Yeah, so this is what is going to give us the ability for me to be able to have a Blazor app and the SignalR element connecting the code on my Raspberry Pi to it so that I can control the Raspberry Pi in real time. So let's see what that looks like. So I'm going to switch right to the main branch here and go all the way to the end. There are several steps in between it, but I'm not going to do that. What I've added here is the elements essentially to be able to communicate over SignalR to my Blazor app, and I'll talk about the Blazor app shortly. So there's a few bits in here that we don't need to worry too much about. All of this is exactly the same pretty much. We're still controlling our servo motor, so we're going to need all of that lot. You see, I've added in ASP.NET core SignalR client into that for our SignalR element, and all of that lot's going to go over HTTP, so we need that. Next up, we create just a global variable here for my hub connection. So this is what's going to do the heavy lifting and the communication between our Pi and the Blazor app. Next up, all of this is pretty much exactly the same. So hello world and our servos and the servo motor starts, that's all exactly as you saw before. And then next, we create our connection to the Blazor app via SignalR. We create using the hub connection builder and a URL. So actually this URL is going to be my PC. And of course, that's communicating to my PC from the Raspberry Pi. So even though I'm viewing all this code on my PC, it's actually running on the Pi, don't forget. So the Blazor app will be running on port 5001, and we're going to call into the chat hub element of that, which I'll show you shortly. Because the Pi is calling into my PC, I had some problems with certificates. I tried loads of different things, and believe me, I did. I spent maybe a day trying to get this to work. And in the end, I just gave up and said, just accept any certificate. I tried loads of different things, and there was a few things on the internet I thought were going to work, but they didn't work. So don't do this in production. Go solve that problem. Tell me how you solved it, because I've just not looked at it since I did this. But yeah, that is, as it says, dangerous, dangerous. Next up here, we've got with automatic reconnect, and that's reasonably important because dangerous settings are the best settings. Yeah, that's where all the fun happens, Brett. Absolutely. Automatic reconnect, if you lose your internet connection, it'll just reconnect. It's actually, it's fine that it works as well as that. Certainly not when we get to one of the demos later. And then we build that connection and get that thing hooked up. Now it's an event-driven system, SignalR is, and it reacts to a particular method that you're listening to, and then you can pass in some stuff to it. Now, if you ever go and do a tutorial on SignalR, I can guarantee you it will be a chat app. It's always a chat app. If you're doing anything with WebSockets, it's always a chat app. That's what it is. A bit like the temperature and humidity sensor for IoT. The SignalR demo is a chat app. And of course, you should always start there because it does work. And so I started there, and then I just usurped it for my own nefarious purposes. So we wait for a particular call to come out, and it's called receive message, this particular one. And into that, I've got a user and a message, which would be your, the user or username of the person chatting and the message that they're saying. But I've usurped that. So the user is actually the servo that I want to control, and message is the angle that I want it to go to. Now, I could have changed all this. Obviously, I could have changed all this to make it look a lot nicer and had servo angle in there. But I just wanted to show you that actually we're not far off a chat app here to get this thing to work. And that's a really important point. All of this code is pretty close to the tutorials that you'll do anyway. And it's all .NET, so it's all running on the Pi. It's all happy. So what I'm doing here is taking the servo, and then I'm calling to my move to angle routine I showed you earlier. And then I'm converting that message into an int32 and passing it into that and moving my servo to the angle that I'm telling it to move at. And I'm doing that for all three servos. And then I just say what that actual piece of code did, which servo it was, or which angle it was for which servo. And then at that point, I start up my connection after I've registered the fact that I'm waiting for that particular message. And then I just sit there doing nothing at all. Just do nothing. There's other ways of doing this, of course. I can't remember what it is. I saw it recently in a piece of code. This is definitely not the way to sit and do nothing. Can't remember what it was now, but there was some way of being able to just sit there and single line of code delayed for forever. And then when it's finished, I stop the servos just like I always have done. So that's great. So that's the Raspberry Pi side, but let's have a quick look at the Blazor app. I'm going to spend a huge amount of time looking at the Blazor app actually. But if I just pull this down here, this is the index file, and I'm going to show you what this looks like in a second, but I wanted to just show you what's under the hood before I did that. It's going to look quite similar actually in some respects to the Pi code. So I'm still pulling in this client. What we've got in this project here is essentially a client for the SignalR hub, and you'll see in a minute that we're going to be utilizing something called hosted Blazor. So if you want to have the SignalR control side, it's going to need to run somewhere central, hosted location. So if you were to host this in the internet, you're going to need the server side of that to host the SignalR elements of it. And then what we've got under the hood then, so we've got the SignalR stuff living in the hosted part of the Blazor app. And then we've actually got a client-side WebAssembly app that is calling into that just the same as the Raspberry Pi. So that's why I've done this SignalR client, because it's going to call in, and I'll circle back, you'll see that. Next, what I wanted to do was have some way of being able to have some fine control over the motion of my robot arm. So I've used sliders, and there wasn't any decent Blazor sliders built in. So I've used this matte Blazor plugin that gives me a matte slider. And it worked quite nice. It's just an open source collection of nice controls, and I'll give a link to that in the slides in a bit. You pass in a bunch of stuff, including the value it's going to be bound to, and that's a property down below you'll see in a minute. There's some other stuff there that we can ignore pretty much. We've got the minimum and maximum there because we've got 180 degrees of freedom, don't forget. So that's all I want to be able to send. And that's about it. We've got some other bits on the end, but they're the two most important parts, is that I've bound it and we've got the minimum and the maximum. And I've got 3 of them because I've got 3 servos. So I've got bound servo 1, servo 2, and servo 3. And then because this is a chat app under the hood, I've also got a list of messages, which is really just the angles I've told it to move the servo to. And then down below, we've got some code. And all of this is going to look quite similar. So I've got a hub connection, but I've also got a list of messages, which is populating this list here. And they're the list of angles I was talking to you earlier about. We've got a hub connection that we build up exactly the same as before. I don't need to worry about trusting any dangerous certificate because this is the same application, so it's just going to work. And we've got the same received message, because actually what I'm doing is I'm adding these messages when it comes back, and you'll sort of see why I'm doing that in a little bit. And then we start up the hub. So all of that's the exact same code, but running in a web app instead. You can actually monitor the state to make sure that your hub is connected if you wanted to. I don't do anything with that because this is demoware, but absolutely really shouldn't try and send stuff over SignalR if it's not connected. And then we do some disposal when we've finished. Then here's the properties I was alluding to earlier on my sliders right at the top. So servo 1 in this case. So when I move my slider, it's bound to this property and it sets this underlying value. And it also then, from our hub connection we created earlier, sends async a send message. So not receive message, but send message to the hub with servo 1 in this particular case and the value that we're sending. So every time I move that slider, it will be calling into this and sending that send message to the hub. And I do that for servo 2, and I do that for servo 3, and then I just set some defaults of where I want it to start up. So that's the client side. That's the front end of our application there. But we've also got the server side. So if I minimize all of this, like you can see, we've got client, server, and shared. So the client side is what I've just shown you, and the server side is where theoretically a lot of your business logic is going to live, and the stuff that's got maybe an API at the end of it or whatever. But it's also going to have our SignalR stuff. There's some stuff you need to do in your startup to get this to work, by the way, like adding in SignalR. I'm not going to explain how to do that because the tutorials will tell you how to do all of this. And then you map some endpoints here so that when I'm hitting that chat hub, and if you remember from my Pi code, that's what I'm calling into, and also from here, that's what I'm calling into up there is that chat hub. So it's just an endpoint. So I've mapped that. So that's what that's doing. But actually the chat hub itself is rather simple. It just lives in hubs, chat hub. And you can see now what happens. So send message is that routine that my index is calling into here, send message. And when that send message is hit with that user and that message, I then send out to all of my clients a receive message with exactly that same user with message. So you can see here I've subscribed to that receive message just the same as I have on the Pi, and that's what's filling up the messages on there. So this client and the Pi is working almost identically. So that is that little bit there. Now I've already got this running actually. So what I'll do first is I'll run my robot, and I did switch to the right branch because I was just showing you it. But if I run my robot up and then we unmaximize this, move it to the side. Oh no, this is bad because it won't let me actually pull my window out of that stupid little tiny window there on the left hand side, and so I can't see it. Can I do that? There we go. And now I need to switch to the right part. Oh, there we are, this way. Oh, geez. Can you see that in the full screen, or has it gone tiny?
No, we can see side-by-side screen.
That's really weird. For me, I've got a tiny little square box in the top left-hand corner of my window, but you can see the full thing, so that's good.
Yeah.
So if I'm I can't move these though because it's in the wrong place. Tell you what, let me just stop sharing and start sharing and see if that fixes it, because it's almost impossible. Right. Oh, that's really bad. Oh. Geez, wonder why it's doing that. Right, let me fix this. Live demos, huh? That's what you want. What am I going to do to solve that? It thinks that window's tiny. Oh, is that? There we go. Ah, there we go. Right. Oh no. Oh, it does. It still thinks it's tiny. Tell you what, I'll drag it to another desktop and we'll work around it. One sec. New desktop. There we go. Go back to this one. You can't see what I'm doing here, of course, because I'm doing it without sharing my screen. That's kind of good because you don't really want to be watching me do that. Oh, this is really rubbish. Right, let's do it this way. How odd. Teams has messed up my setup here, which is just silly. Right, getting there, getting there, getting there. Right, one of these. And one of these. All right, let's share my screen and hope that it doesn't ruin everything again for me. That one. Yeah, that looks a bit better now. I can actually control all of this. There we go. Right, can you see that?
Yep.
Yep.
Ah, that's good then. I had no idea why it's done that. It was very silly. But anyway, yeah, so this is Servo 1, and you can see that's doing the rotation. It doesn't look mega smooth because my PC is under enormous pressure, as it's just demonstrated to you. And then Servo 2, that's doing what's called the reach. You'll notice actually, and you'll notice it even more later, that I kind of made a sort of mistake when I was doing this in that I've not screwed that down, look. So it's really wobbly. That's my wobbly robot arm. When I created it, I should have screwed the servo into the base, but I didn't. And to screw it in now, take the whole thing to bits, and I'm not doing that. But actually, it's really handy because if I want to travel with it, I can actually take the top off, and it doesn't take up all that space that you can see there. So it's quite useful. This Servo 3 here, you can see that's the grip. You see that moving? It's pretty smooth actually, isn't it? And that's the software controlled PWM there. So that's what I mean. I find actually that oddly, whether it's just because it's the gripper or not, I don't know, I find that to be smoother than the hardware PWMs. So yeah, that's quite cool. So I can get rid of that. All right, destroy this desktop that's gone all wrong, all on its own. Desktop 2, desktop 3, desktop 4, that one. Nah, no. Right, so that's running. That's all running locally, and that's great. I'm happy with that. And essentially, again, I could just stop at this point and say, whoa, look, we have our Raspberry Pi, Blazor, SignalR, robot arm all working. But I'm not going to do that. I'm not going to stop there because we have more interesting things to talk about. Normally in person, I would demo something called the Uno platform. And I mentioned this earlier without actually mentioning the name. But Uno platform is a way for us to be able to get XAML onto our Pi. So these folks over at Uno have done a load of work, including Jerome Laban sort of created the project. And actually he's got a Twitch channel himself and he live codes this platform on that Twitch channel, which is quite cool. But it gives us a way to be able to have UWP, Universal Windows Platform, and XAML and C# all on our Raspberry Pi. It's all open source and cross-platform. I think it's Uno Platform 4 and WinUI 3 it's using under the hood. It actually utilizes something called Skier and GTK, which are the toolkits to be able to get graphics on Linux operating systems historically. And if you've ever tried to use that with something like Mono, oh, it's awful. Yeah, it's not good. I mean, I don't know, maybe it is if you're used to it, but I tried using it and it was awful. And I quite like XAML, WPF, and all those things. So this just works for me. And yeah, so this is the way to be able to get the UI on the Pi. So the demo that I would normally show would show me dialing into the Pi, and you can move the same sliders, although not the matte Blazor ones, because this is actually a XAML application, a UWP application. But XAML sliders, you can move it and control your Pi just all together with a little touchscreen if you wanted to. So yeah, I've done that. But running it, because I deploy it remotely from a PC to the Pi to do that, just kills any video sharing that I'm doing. So yeah, I gave up demoing that. But go and check that out on that bit.ly there. It's definitely worth checking out if you want to just stick to your Pi. But actually, I want to talk to you about Unity and VR. This is great. This is a cross-platform game development engine. But what's great about it is that actually it's C#. It's been around for ages as well, since 2002, created by those folks, Nicholas Francis, Joachim Ante, and David Helgeson. And it supports VR headsets like the Oculus Quest 2 that I've got. And it's also C# and .NET standard. So you can do pretty much anything that you would in .NET on the Oculus Quest, which is lovely. So I did that. When I realized that obviously you could use .NET on there, I thought, oh, I wonder, can I get SignalR to work from my Quest and then control my robot arm using my new Quest? And I could, so I did. So let's look what that looks like, shall we? So I need to stop this code and make a very quick change to the code for the Pi, which is this one. So at the moment, this is connecting out to my PC, which is great if I'm running it locally. But actually, I'm going to connect out to a Azure hosted environment instead. So all of that lot can go, and I can call out to that. Now, if I go to the chat and pop that address in there, you too can control the robot arm. So if I do this, there we go. So if you want to, you can go to that address, and when I run this code back up again, you too will be able to control the robot arm, which is cool. So I'll save that and then run it. And then I'm going to go over here and switch to, actually, is it this one I want to do? Yeah, that one there. That one will work. Oh, look, see, somebody's gone to it and they're controlling it. Now, what happens is when I give people control, they make it do crazy things. So I always have to say, don't do crazy things at the minute, because I'm just about to show you something cool with the VR. But do feel free to move it around. You can absolutely. In fact, I implore you to. But what happens is if you do it too crazy, the whole thing falls off. And then I can't see because I've got my head in an Oculus Quest. And it's not ideal. And in actual fact, look, this is that same app running, or at least it would be if I switch to the right one. Let's do BCS there. Oh, in fact, you can see it yourself. I don't need to show you, but in your browser, you're moving that, and it's actually moving my robot arm, sending those messages over SignalR exactly the same way. So if you can see me on the camera, here's my Quest and the controller. I'll bring this one over as well. Turn my Quest on. This is the part that is always a bit clanky because trying to get it to work sometimes is a little bit hard, but it's still cool, so it's worth waiting for. So, do this. I'll reset my floor level. Oh, you can't see anything I'm doing here, so I'm talking to myself essentially. Switch to a stationary boundary, that's fine. And then I can go to my apps. And I'll get it started up. should be able to cast this to my computer. And all being well in a second, you should see, there we are. So there's a robot arm. Right, someone try moving the arm. Go on, tell me you've still got it open. There you go, look. Oh no, what happened? It's lost for tracking, don't worry about it, it's fine. There we go. So you are moving the arm and it's moving in VR. You see that? It's good, it's good. It's actually moving. You should be able to see it on the screen on the left-hand side as well. And I can move it too at the same time. Oh! And somebody moved it that way. And grab. There you go. That's just the reach that's moved. The grab. Interestingly, I broke the grab with me moving it a while back. But if somebody else moves the grab, you'll see it does actually work. It's just. There you are. There you go. So it does actually work. For some reason, it just doesn't work when I'm doing it. Don't know why.
We
fell over in real life.
We broke it.
Oh, you git. There you go. I told you. I did tell you about that. No, there we are. So yeah. So that should be. There you go. Moving that grab. So there you go. So that's it running in VR. So I mean, you would say that that's like, oh, you know, that's really fun. What's the point of that? But have you seen that advert with Kevin Bacon for EE where he's shaving somebody with a remote robot arm? You could also say, why would you do that? But actually, people are using this exact same technology. All right, not this exact same technology, but a similar sort of idea to be able to do remote surgeries. So, you know, a qualified surgeon will be able to use something like this to be able to do surgery on the space station from Earth, for instance. That's sort of an idea. So that's what you know, the benefits of learning this sort of tech is. Yeah, or you know, go ahead and kick a ball around. There's a ball over there. You can kick that as well if you want. But yeah, there you go. So that is how you can control a Raspberry Pi robot arm with Blazor, SignalR, and Unity VR and a Quest headset. So there you go. What I'm going to do though is I'm going to stop that code because otherwise you're going to have too much fun, and we don't want that. So there you go. It didn't all go according to plan. My cat seemed to like the sound of these and would come over and start biting them. Also, it was really jerky to begin with. As I mentioned about the software PWM, it just didn't work very well until I did that thing. And also, it's not screwed down. So like you saw, you know, do the wrong thing and suddenly it's going to fall over. So yeah, but it's all good fun. That's part of the learning process. So there's a bunch of links here. There's a workshop version of this. You can build this very same robot arm, or you can build a slightly simpler one. Cliff Aegis, who I mentioned a few times now, his son is all into 3D modeling, and he was able to create a far simpler version of this robot arm. Probably took me about an hour to build mine, and then I had to find bolts and screws and all sorts. Whereas the version that Cliff's son's created is way simpler. And when you buy these servos, they come with a screw, and you use that screw to screw together the bits of the robot arm, and it just works. So you just need to 3D print 3 or 4 pieces of flat PLA out, and off you go. It works quite easily. It's not too bad. If you want to find out about C# 9 and .NET 6, then you go look at that there. And if you want to follow my blog on how to get .NET 6 running on your Raspberry Pi, then hit that bit.ly up .NET 6 Pi. If you want to go and have a look at the information for that GPIO NuGet package, then you can find that there. And there is the link to the source code for the device bindings NuGet package, and that shows you all of the devices that are included in that, and it's fantastic. I stole my 3D printed robot arm from Thingiverse. That's the original link for that. And there is the workshop for that 3D printed robot arm with the parts, in fact, for it just there. A few other links. There's a link to some information about Blazor. Go ahead and find that out. The link to Map Blazor that I mentioned, that open source collection of controls. Awesome Blazor. While I'm talking about it, go and check that out. And that's a collection of all sorts of cool Blazor stuff. And then some more information about SignalR and Uno platform. I mentioned IoT Live, so it's worth going and checking out our show. We are live on there in the future, just not at the moment, but there are previous recordings on YouTube you can go and find on my YouTube channel. If you want to do something a bit more professional with IoT, as I said, I've been involved with the Microsoft Azure IoT stack for quite some time now. I actually co-created the exam, so the AZ220 exam for Microsoft, and I'm still involved in keeping that exam up to date. And in fact, we're going through a refresh at the moment on that exam, so there's some new questions coming. But I'm a Pluralsight author, and I've also created a course that helps you pass that exam. And obviously, as I help create the exam, you'd hope that the content would be all right for that. There's a few other authors as well who've created some content to go with that. I'm not the only one, but do go and check that out at that link there at the top. There's a couple of Octopus Deploy webinars coming up there, nothing to do with IoT whatsoever, but I would be very remiss in my job, in my role at Octopus Deploy, to not tell you about these. Derek Campbell, along with myself, will be talking about introducing config as code on Wednesday, the 4th of May. There'll be sessions to suit you. There's 3 across the day, so just pick one, come and watch that. And then myself and Chris Reddington from Microsoft will be talking about GitHub Actions and Octopus Deploy on May 18th. So go and check that out. I've been working on that today, actually, that webinar, and I'm learning a lot about not only GitHub Actions, but also Octopus Deploy, which is pretty important. Yeah, Bill Ayers is saying they only joined the call 15 minutes ago and he already broke it. Yeah, stop it. Don't break it. Naughty. So if you want to get in touch with me, Twitter is by far the best. That's actually Pete_codes there. It's not particularly obvious, but hit me up on Twitter if you need anything. You can email me if you like, at my new Octopus email address there. I've got a whole heap of blogs up at Pete Codes. I've not done much blogging recently, actually, but do go and check that out. I mentioned that I run a few user groups. So Knots IoT, you can see there. Go and check that out. We've got All Been Well. I need to chase him up, but we should have Lauren Allerbach from Microsoft talking about the .NET Nano framework on May, what do I want to say, 12th, 13th, something like that. Forget what the date is now. I need to put that up onto Meetup, but you'll see that if you follow Knots IoT on Twitter. .NET Knots, I forget who we've got next month, but that's the last Monday of the month normally. It's Steve Collins we've got next month, I think, talking about source code generation, so that'll be fun. Knots Dev Workshop when we go back. Wayne's played with Nano Framework. Yeah, it's really good, actually. Jose Samoes, we've had quite a lot of dealings with Jose. He helped create that, and that is a way to be able to get .NET onto little devices like ESP32's microcontrollers. Yeah, there we are, and Wayne did exactly that. I thought it was all OS and not supported by MS. It is, but actually they're part of the .NET Foundation, so they get their support from Microsoft that way. But yeah, it's open source, so everybody can contribute to that. It's a fantastic project. Yeah, worth checking out. I actually give a very small demo of that in a talk that I'm going to give next week, which I really should have put a slide for as well. But if you're interested in finding out how to control your home using the Azure Percept and cognitive services and Lewis and stuff like that, and a Raspberry Pi, then next Thursday for AI 42, I'll be giving a talk on that. So do go and check that out. You'll find that be tweeted out on Twitter, no doubt. Yeah, no worries at all, Wayne. Thank you for coming. I mentioned as well Lati, a Loughborough-based engineering meetup group. They're there. Agile Engineering Podcast with my fellow co-hosts. That's well worth checking out. And the Azure-ish Live Twitch channel, which there's not a huge amount going on there at the moment because we're paused. And the slides, you can grab them at that bit.ly. I have uploaded them, and of course, since I uploaded them, I edited them ever so slightly, but that's normal. But the bulk of the information is still there. It's all good. And that's about it. So yeah, go ahead. In fact, I'll leave it on that, so in case you might need the slides. But that's the end of my talk. So thank you very much. I like that talk. I've given it so many times. I'm used to giving it. I'm not used to Teams breaking my screen. It's silly.
OBS and virtual cam.
Yeah, you know what happens when you do that though is that OBS's virtual cam optimizes the stream for image, and it doesn't work very well with code. So gotcha. Yeah,
Yeah,
I think you've got to have like a really good setup to make that work half decently. But yeah, it can work.
Great stuff. Good, really interesting.
Yeah,
You've basically you've done all the stuff that I've been wanting to do for the last 12 months.
Well, now you've got a GitHub repo you can go and clone and do it yourself.
Indeed.
I'm going to stop sharing now.
Okay.
There you go. So yeah, so that was good. I hope you enjoyed it. I mean, obviously, if you've got any questions, now's the time.
I'm actually good.
Yep.
I just thought I'd just speak rather than type.
Yeah, you can do that. Go on.
No, I was just going to say, somebody mentioned about only seeing the last half hour. I will be editing the video and sticking it up on YouTube the next couple of days. So if you didn't see the beginning, then's your opportunity to.
Awesome. You can edit out the part where my screen broke then, can't you? And nobody has to watch that ever again.
I don't know what you mean.
Of course you don't. Awesome.
So has the Nano framework got better support? Because I found the device or the control or the libraries, I should say, for the devices lacking.
Yeah, it's still relatively new.
Yeah.
Although it's been around for a couple of years, it's still relatively new, but it is well supported. And Jose Samoes has been supporting that, and there's quite a few other people now. Lauren Ellerbach, as I mentioned, has been involved in that project as well. It works quite well. There's some stuff that works, some stuff that doesn't, but they're going through quite a lot of work to try and bring stuff in. There is an alternative as well. If you didn't want to do that, there's something called Wilderness Labs, and
I've heard of that.
Yes. Yeah. So they've made a board that's full .NET compatible. Yeah,
I think I looked at that, and I kind of thought I looked at that and looked at an ESP32 and thought, well, that's really expensive in comparison.
Yep. Yeah. One of the reasons is that obviously they're paying a lot of people to do it. It's not open source.
Yes. Exactly.
But the other one is actually it's a coprocessor based system, and the coprocessor on it is an ESP32.
Yeah.
So yeah, they've got an ARM chip on there and an ESP32 working side by side, and they're still in their infancy as well, really. And then Peter Bull's mentioned Uno platform. I like that. It's dead good. That works quite nicely. I've got a few blogs. In fact, if you go to the Uno platform, the Uno website, then you'll find there's a blog on there that I've written about how to get started with the Raspberry Pi and Uno. So there we are. So Tim's saying that he's got a Meadow as well. So yeah, Meadow F7 is the name of the board you can buy. You're right. I think it's 40 or 50 quid for the board. It's quite expensive
in comparison to other smaller boards and what's out there.
Yeah, you get about 15
Picos and whatnot.
Yeah, exactly. Yeah, I think somebody's actually ported Nano Framework to a Pico.
I think I tried it on the Pico as well when I was messing with the ESP32.
How'd it work?
It worked. Yeah. To my shock and astonishment, I sat there with my mouth open, going, "It's running on a £4 little computer thingy majiggy microcontroller."
Pretty impressive.
Yeah.
You can't do much with in the IoT with a Pico though, can you? There's not much internet because it's got no Bluetooth or Wi-Fi. But
also yes, and the reason why I'm going to say that is because Arduino's brought out one it's got a microphone built in. It's got wireless and Bluetooth.
Yep. Yeah,
and that's about cool. £20.
Yeah, it'd be similar to the BLE Sense board that they've got, but the Pico version of that. Yeah, I remember seeing that advertised actually.
Yeah,
I need to buy
almost
all
bought
the things.
One, but it's a slippery slope. You just buy all these things. I've got so many toys around here, and I just don't play with them enough because I haven't got enough time.
Yeah. I've got another talk I give on just an introduction to IoT. Actually, it's an IoT with nothing but your laptop, so you can do all of it without the actual kit. But yeah, most people buy a Raspberry Pi and it just gets slung in a drawer and they don't use it.
Oh no! I've got a Pi running my 3D printer, a Pi running the Home Assistant. I've got a Pi cluster, and something else. Can't remember what the other one's doing.
Cluster as well. Nice.
Yeah.
Mind you, that Pi cluster's worth more than your house now. You realise?
Yeah, I know. I've had a customer who was desperate for a Pi. He was absolutely desperate for a Pi, and he rang me up and said, "Have you got any?" I went, "Yeah." He goes, "Can I have some?" I went, "No."
Yeah, definitely
because the gold dust.
I'll swap you your car for it.
Yeah.
Brett's asking, can you run .NET 6 in Docker on a Pi? Yes. Is the answer. It takes a little bit of setup because you have to give it the permissions to be able to access the GPIO. So you have to run it elevated when you do that. But actually, what you're doing almost is Azure IoT Edge. That's almost what you're doing, because that's essentially what Azure IoT Edge lets you do. So if you're going to go that far, I would consider looking at IoT Edge instead, and then you get some benefits to that, because you're off and running with that. And there's a free tier with Azure IoT Edge and everything, so you don't even need to pay for it. But yeah, absolutely, if Docker's your thing, then go ahead and do that. Worth doing. I gave another demo, a DevOps demo, which I don't give anymore because it's horrendously complicated, where I compare IoT Edge and then the open source equivalent of that then, where you can then look at how you can keep the whole thing up to date with something like Jenkins and Docker Hub, and then something called Lighthouse, which polls Docker Hub to a degree and looks for the latest versions of the Docker images that you put up there and automatically pulls them down onto your Pi and carries on running. It pretty much only does Hello World, that particular demo, but you'll probably find that talk on the internet if you want to go and check that out. So yeah, Pi Moroni have got the RPi 3 back installed, the Pi 3. Who wants a Pi 3? I don't know.
That's all you can get.
It's ridiculous, isn't it?
It's a Pi 4 gig or above. That's
yeah.
Cheaper
I
than
gave
an old laptop and throwing Linux on it at this point.
Yeah.
Well, yeah.
I knew a guy, a little boy who's, I think he's like 10, and he wanted a Pi, and he wanted it for his birthday. And he was so excited, and then you're looking online going, oh my god, I can't find one. So I ended up having to give him one of mine, just so then he had something, because as being a STEM ambassador, the last thing you want to do is say, oh no, there are none available. So
I believe the 400's in stock.
It is, yeah. But the reason for a lot of this is that obviously the chip shortage, we all know that, but actually Eben Upton tweeted a blog about this just recently, and they're prioritizing industrial customers, and it's actually really sad because that's not why they created the Pi.
Yeah.
But unfortunately, that's where the money comes from, that they need to carry on developing them, and that's the reason why you can get the Pi 400, because industrial customers aren't using it, and the Pico, same reason.
Yes.
So yeah.
Yes. I mean,
another problem is the scalpers.
Oh God,
yes.
Yeah. Well, yeah. But that's why all of the official distributors will only sell you one. So
Or you could go onto eBay and pay double the price.
Oh yeah, absolutely, nothing wrong with that.
If you're really that desperate.
At least double the price of Amazon. God knows what you'll get.
I managed to get a model Raspberry Pi 4 from Pi Moroni about, I think it was last week. They briefly had them in stock, and I got one.
I presume we all know about the Pi Locator website.
Yeah.
No, actually, it's not heard of that one.
RPI Locator. It's a bit addictive, actually.
It is a bit addictive, isn't it?
Yeah.
PiLocator.com, that one.
You don't even want one, but you can't stop yourself checking.
Yeah, exactly. It sounds like we've got a problem.
Yeah. It looks like Adafruit have got them in for
addiction.
£75 in the US if you want them.
Well, that's the problem in the US. The link I posted, it's got filters the UK to make it a bit more relevant.
That's where I'm actually. But how do you filter it? You just type UK in. Oh no, you've got regions at the top, haven't you? There.
There's a little drop down at the top. Yeah.
Yeah. No. Yeah.
I really want some Pi Zeros, 2s, I should say. And some came in stock last week, and I was on a phone call and I saw them. I had Pi Locator open and I saw them, and I clicked, and by the time I got off the call, they were gone, and it was literally like a 5-minute call.
Bastards.
All gone.
They're robot. They've got robots. Scalpers have got robots, and somehow get around the one per customer thing somehow.
Well, probably by setting up many customer accounts.
The 02 is nice though, because I bought one because I was in Cambridge and I went to the Pi shop, and I was going to get. I want a nano.
Zero.
Zero. I mean, and the guy said, maybe you should get a model the 2. And I thought, okay then. And then I realized you could run .NET on it.
Mhm.
.NET Core.
That's why the Pi 2 for the longest time, I tried to it's a very long story. I needed the Pi 2 to run .NET, short version, and then I can't get
mono.
them now.
Yeah, I think the Pi 2 did run. Did it run? I think it did run .NET, didn't it? As long as it wasn't the Pi 2A or something funny like that.
I didn't try it on. I tried it on 3 only. I think I don't think I ever tried it on the 2.
Yeah,
But
well, I did mono development on the original Pi. Oh, that was awful.
Wow.
Oh my
yeah,
god.
mate, that was slow.
Yeah.
Because I wanted the Pi 2 zero form factor to stick inside of a little case, you see, but run a .NET app on it.
Okay.
Yeah.
Jeez.
But,
Yeah, I've got
it's amazing what I mean. I always think back to when I was like, I'm in my 40s now, and I just think back about being in school, and what we're doing now is just sci-fi.
Yeah. Yeah, it's incredible for the price. The Pico you mentioned, incredible.
The Pico. I mean, that thing's a BBC Micro if you want it to be.
Yeah.
Crazy. The 3D printing of it, the whole internet infrastructure behind it, what you've just demonstrated this evening, that you've put together. It's amazing.
Yeah.
Blows my mind. Really does.
You can go out now and print a BBC Micro case.
Yeah.
To go and put your Pi
little
in
micro.
Exactly.
Oh. Can you see behind me over there? That's used to be a desk over there, but I've replaced it because I'm on camera quite a lot, so it needs to look a bit better than it did before. I didn't mind when it was in the community, but I don't know if I've gone really jerky. My PC seems to have gone really jerky, but either way. But that's a bunch of retro consoles. But in the loft, I've got all of my retro PCs, if you will, or the computers. I've got a BBC Micro, an original BBC Micro up there, and a few other computers. So yeah, I got
rid of all mine.
Oh no!
I know. It all went a long time ago now.
Damn.
I know.
Tell me it went somewhere nice though, and not just to the tip like a lot of people do.
No, I sold a lot of it at the time.
Right.
I was young and wanted money.
That's the problem. I had a CD32 back in the day, and I sold it for a CD-ROM drive for my A1200, my Amiga 1200, and wish I'd never done that because those things were a fortune now.
Yeah, they are. Yeah.
I don't want one. I wouldn't play it, but I want one just because.
Just in the collection.
Yeah, exactly.
Are you a RMC, a Retro Man Cave fan on YouTube then?
Yeah, I've seen that. Yes.
Yeah.
I mean, I've kind of got that now a little bit myself. If I had more space, I'd do more with it. But I've got all sorts of stuff in the loft there. I don't know. I've got an Electron Sam Coupe. Have you ever heard of one of them?
Sam Coupe? I don't think so.
It's like a Super Spectrum. It came out not long after not long before the Amiga came out, which unfortunately is what killed it. But it ran like Spectrum software, but it ran it and it had graphics probably a bit more like the Amiga would have been rather than the Spectrum. Yeah, have you heard of the ZX Spectrum Next?
Yes.
Yeah, it's a little bit like that, but it was in 1992. So same sort of idea. So yeah, they're quite rare. Go and have a look how much they are on eBay. I had one of those as a kid, and I sold that and bought an Amiga with it, I think. And then wish I'd never had, but then since managed to get them again. But yeah.
I used to work in a small computer shop back in the day, in the early to mid 90s it would have been, and it was all Amigas, the A500s and the original Amigas, and there's Electrons in there and all sorts. And if I could go back in time and take one of each,
oh, imagine, yeah,
it was all in there. Amstrads, everything you could think of.
Yeah. Yeah, the Atari Jaguar had a CD that you could put on top of it, and they were selling those off for about 20 quid, like in big boxes, and now they're about 600 quid, like really rare. They're not rare, I'm telling you, somebody's got a garage full of them, and they just release one every now and again.
Yeah, just making a load of money.
Yeah, definitely. Here's an unboxed
release one every 2 or 3 years. Oh, look, another one serviced. Oh, magical.
Yeah, don't need a pension. Just need a garage full of Jaguar CD drives. Yeah.
But this is the thing, isn't it? You keep all sorts of things. It'll be worth something one day, and the stuff that you keep isn't, and the stuff that you don't think is going to be worth something is.
Yeah. Like, well, my wife's dad, so my father-in-law, he used to work for Palatoy, and I don't know whether you know, but Palatoy used to make all of the Star Wars figures, and he used to bring home boxed Star Wars figures and just open them up, chuck the box away, let the kids play with them, rip the heads off them, and and of course now if you had boxed, imagine if you like boxed originals, or even ones that he brought home ones that were off a run that went wrong as well, of course.
The other
So
worth so much money.
Often ones with defects end up worth more, don't they? Because they're rarer.
Rare.
So
Exactly.
Yeah.
I had a friend of the family when I was a kid that used to work at Ladybird Books and used to bring home Ladybird books with the covers on backwards like that. And of course, we drew all over them and chucked them in the bin. But they would be worth money now too, even. So, geez, you're right. You don't keep this stuff that you think is going to be.
It's sickening, really. But
yeah. I have got my original Star Wars figures in the loft, though. They would be original, but they're not worth anything much because they're just knackered.
Crazy.
In fact, they'll make an appearance at my talk on May 4th, obviously.
May 4th,
yeah. So there's going to be a little Star Wars element to that talk. If I get time to flipping do it, that is, because that's like next Wednesday now, and I need to. Bill's going. Nice to hear from you, Bill. See you later.
Bye, Bill. I've lost chat. I don't know what I've done with the chat.
Oh, wrong tenant. Cool. Right.
Thank you very much for the talk. Really enjoyed it. Thank you.
Thanks for coming. I'm glad you enjoyed it. Apologies for the broken screen in the middle there, but that aside, I think it went all right.
Yeah, that was fine. All good. These things happen, especially when you're doing it live.
Yeah, and you got so many remote desktops, so many virtual desktops. Yeah, that's going to happen.
That way,
Cool.
Nice. Okay, I'll speak to you on the interwebs.
Absolutely. Thanks very much. Thanks for having me, and get in touch if you need anything.
Will do. Cheers.
See you later, folks.
We're busy lining up. Feel free to drop off, but we're busy lining up the next couple of months. So if there's anything you want to see specifically, we're looking to get an Uno platform talk. We got contacted by somebody when I was promoting this one on the .NET Twitter community. So if there's anything you want to see, if there's any particular topics or but yeah, we just keep an eye out on Twitter. We'll be sharing the next couple of months. So I've just changed jobs. I used to work with Derek at Sage, so I've got a bit more free time on my hands now.
Right.
I say that I'm getting a new puppy on Friday, so that's probably about to evaporate.
Okay.
But hopefully we'll be able to get some forward scheduling done so we can get the stuff advertised a bit sooner. So
if you like the IoT stuff, then talk to Cliff Aegis. I've mentioned his name quite a few times. His ears will be burning tonight, but yeah, he's got a few cracking talks.
I'll drop my message.
Dylan Hayes for 11th of May, and we might see if we get somebody, somebody talking about Uno or something. Wink, wink to Peter. There, because he just mentioned he might be able to do something with that, so that would be good.
Awesome.
And then, as I say, I've got a few other things coming up, but they just need to be firmed up a little bit, don't they? We just need to nail people down to dates.
Yeah, Derek and I realised that since I left Sage, we no longer have access to our planning, our planning board, because that was internal. So we've had to reconfigure that so that we've got access to it all again. So
Trello, that's what I use.
that's what I've set up. I've set up Trello, but we were using Planner internally on Teams originally, and then it wasn't until recently I was like, I don't have access to this anymore. Oops.
Oh. Don't know who all the speakers are now. Damn it.
Yeah. So.
I'm at MDC London in a couple of weeks' time, by the way. So if anybody on the call is down there, then do say hello if you're ending up going to that. I know some people, it's not a I'm just going to go sort of thing. It's work sending me to something like that. But either way, I'll be down there, and actually I'll be running Not IoT from my hotel room because it happened to coincide with that day. So
cool. But we'll keep Twitter up to date, and hopefully get the upcoming talks published a bit sooner. And if there's anything you want to see, reach out to Derek or I, and we'll happily accommodate.
Sounds good. Thanks, Dan, as well, for the message in there. Thanks for the comment. That's good of you.
Cool.
All right. See you later, folks.
Cheers.
Excellent. Thanks all for joining.
Thanks, Dan.
Cheers.
Bye-bye.
Bye.
Cheers. Bye.
Bye-bye.